Hi, this is Mike WA3TTS, and this is a video about common mode chokes. More specifically about the kind of common mode chokes that some of us are making with Cat5 wire. This one's about 15 millihenries, and it's good for 100 kilohertz or a little lower, up to about 2 megahertz before the standing wave starts to get up a little higher. Now, I've got another one in a tin can right here, and we're measuring the choking attenuation of it. And I don't know if we can see inside the lop here or not, but we're getting like 46 dB of attenuation, choking attenuation at 188 kilohertz. This is the upper part of a loafer band. And if I take this, I have one of the wires of the choke grounded to this tin can. If I take this off, the choking will go down by about a dB. It doesn't really affect the, well, I see here now, I see 45.2 or so. I don't know if the camera will pick that up. Okay, but apparently it works pretty good that you can put this inside a tin can and get some broadcast attenuation. To show you more or less how effective that is, take my little pocket transistor radio and we'll get the local 50 kilowatt station on here.
Supreme Court, and he will not answer the question of whether he will pack the court or not.
So that went away when I put it in a tin can, and that's a 50 kilowatt station about 4.5 miles away. It's pretty impressive. And one thing that's really useful to note here, if I turn this thing 90 degrees, I start to get signal. So the orientation of your common mode choke relative to your noise source makes a difference when you do this. I mean, you can just put your common mode choke inside a tin can and get some choking, but you might get 10 or 20 dB more if you orient it correctly so that the noise source is really being minimized because of the nature of the choke, whether it's on a rod or a toroid core or whatever. So that's something to think about. I've been having some reasonably good luck lately on 137 kilohertz with some fairly good receptions of WH2XND compared to NO3M up in the boondocks with, you know, less noise issues than I have in suburbia. So I just wanted to point this out and suggest that it might be useful. Now, what I've done with these common mode chokes, to put them in cans, I put them in a jar such that I can space them so they're a few inches above the bottom of the can and a few inches around the can, so that, you know, ideally you might want a toroid diameter clearance all the way around it to minimize the effect of the anticapacitance of the can and still get some decent shielding. Now, if you do ground one side of the can to one of these, it would be better to ground the side of the can on the coax that's going back to the shack, and then make sure the midpoint of that coax is grounded someplace to pull the energy away from your antenna. That would seem to be what makes more sense to me. But anyway, that's what I've been fooling around with very little spare time I've had lately, and this does seem to make a difference as far as choking. I do want to do some more experiments with these Cat5 wire type chokes at an EHF band with, you know, different cores, and see how they respond up there. I've always used coaxial chokes before, and they're broad-banded, but they also have higher losses because of the very small center conductor wire in the 174 cable. So, you know, these chokes are probably a dB or so more efficient, and, you know, really low loss at 188 kilohertz. I was seeing, you know, 0.02 or 0.03 dB insertion loss, and, you know, pretty much flat standing wave. So, you know, they work well. They get to about 2 megahertz, and I start to see 1.25 to 1 or so on 160 meter band. And above that, you know, the standing wave starts to go up. But as far as low frequency and medium wave bands, they work really well. So getting this little Nano VNA has been really useful in being able to check things. And I can't say enough about a $50 instrument that can teach you a whole bunch of things. 7.3 from WA3TTS. This was a good experience here. Take care.